So today on DIY Solar Power with Papa, we bought a Hyper Engineering soft start to put on this inverter that could not start up a 3.5 ton heat pump air conditioner. So right now we just got done installing that, and I'll show you the mistake we made that kept it from staying running. And I was actually watching another video by somebody else, and apparently on their air conditioner it did make a difference, but on mine it made a difference. So anyways, we are running our 4-ton downstairs on this one, and if we look at it, our battery's 48-volt battery bank staying at 51.8, and we're bringing in 3.92 kilowatts on this. And our load is 31%, which is 3.66 kilowatts. And we're draining no amps out of our battery. So we are completely running the downstairs air conditioner off of this. Now on this one, this is the upstairs 3.5 ton. And this one is bringing in 71 amps. The PV solar panels are bringing in 3.87. And down here, our load is, it's a 48% on the 6 kilowatt inverter. And we are using 2.85 kilowatts. And once again, we're not draining anything on our batteries. And our battery, 48-volt battery bank, is staying at 53.9 volts. And it is almost 11 o'clock. So if we go outside, probably going to get another one of these for my 4-ton air conditioner. Now I'm going to be able to run my 3.5 and 4-ton from sun up to sundown, and I won't have any problem starting them or running them on my. So this is the 4-ton running on solar that is the downstairs of our house, and our house is 2450 square feet, and it's about 700 or 800 square feet in the garage that we air condition as well, but we use a 18,000 BTU mini split for that. So over here is our 3.5 ton that we're actually running on that 6 kilowatt Growatt low frequency off-grid inverter. Now, here's the soft start that we got, Hyper Engineering. So when we originally wired this up, I was watching somebody else installing this, and the mistake that they made was this brown wire coming here off of our run capacitor, they were running to the brown wire back there, and that's for the fan. The compressor is the yellow one, so we needed to run this brown to our yellow. So we actually, right now we're running 10 amps on our current that we're using. So what we did was we cut this yellow wire right here. It was connected here, and then we fed that up into our Hyper Start. Sometimes it's a red wire. Then the next wire that we did was our brown wire, comes out of here, and that goes into your C. I don't know if you can see on there for that yellow. There's a C, there's a Herm, and then in the back behind that brown wire it says fan. So we're going to run that brown wire into our C that goes also over to where we pulled out this yellow wire. That's where that connection goes between those two. Then the next wire is this red one that they supplied all these wires. So this red one goes back to there where we originally disconnected this yellow right here and connected it up on top. Then the next wire is the blue wire and that is off of our start winding, and that one actually goes to the blue, which is the Herm on the capacitor. Then the last wire is the black wire that connects down here in the green. That blue one also connects in the top of the green. So this black wire is the common for the compressor. That middle one is not used, that middle space. So this black wire runs all the way over to the common side on the compressor. So once we had that connected, it was starting up when I accidentally had this brown wire with the brown wire for the fan instead of for the compressor. But then it would only run for a minute or two and then shut down. So we were pulling 72 to 75 inrush amps when we were starting this thing up. And it's anywhere between 16 and 24 right now. So this thing's been running for about 15 minutes. It's actually staying running, so it looks like it's all set. Now, this was $250 delivered to my door, and I just went online and Googled Hyper Engineering soft start, and it pulled it up. And this is actually the 1632 model right there. I don't know if you can see, but it's a part number SS1B16-32SN. So this is the one I use for my 3.5 ton, and I would also use it for my 4 ton. Now, if you want to know something on your inrush for your compressor, if you look on your compressor on your panel, it's going to tell you that it's 1 phase or 3 phase. This is your running amps, and then this is your inrush amps, and there's your hertz and your voltage 208 or 230. So right now, this is saying my running amps on here should be around 15, and it's actually around 10 or 11. So this thing's working great right now. We're not having any problems with it, and I can't believe with these 2 Growatt, 6 kilowatt and 12 kilowatt, we have one each running our main air conditioners, and we'll be able to run these from sun up to sundown, because like I said, the inrush on this was 72 to 75 amps, and I was able to start both of these air conditioners with that 12 kilowatt, but I couldn't start either one with a 6 kilowatt. That's why I needed this soft start. So the benefit is we still have plenty of extra electricity we're producing to be able to run some other things on here. If we go inside again and we go and look at our inverters, it's we got the downstairs set at 74 and it's 76 right now, and it's actually about 108 degrees outside right now. That's not bad. I've only had the downstairs running for about 25 minutes, and the upstairs has only been running for about 10-15 minutes. So, and we are running both of these air conditioners using these AGM battery banks. There's 4 AGMs in series for 48 volts, another 4 on the bottom, and then you can see we actually brought both of those in. So we have 2 negatives, 2 positives coming in. Now we have the same thing over here. We have 2 negatives, 2 positives on there, and that's going into these over here. Now, what I had a problem before was being able to start up either one of these air conditioners with this 51.2 volt, 100 amp hour, 5120 watt hour lithium iron phosphate battery bank. I couldn't get it to start. With this, I should be able to fire that up and be able to use this instead of the AGM banks. We'll do that on another video, but let's see. So here's the instruction guide that they give you for this. So they give you a basic schematic of just a simple wiring schematic on a compressor, and then they show you down here how you would run those. Now, in a video I was trying to watch of somebody that was wiring this up, they were taking this brown wire here and running it into the fan when it actually needs to go into the C as it's showing on the schematic. So, and don't make the same mistake that I did. It was an easy fix, didn't hurt anything. But then they also give you a little bit of an explanation down here. They give you a parts list. And they actually give you some pictures of how to install it. First, you're going to disconnect the power. Then you're going to take and mount your bracket to hold your soft start. Then they're telling you to take off your red wire. In my case, it was the yellow wire, and you're going to put it in the very top right here, the very top part of your soft start. Then they're going to have you take your brown wire and run that into your C on your capacitor. Then you're actually going to take and run your black wire into this green terminal on your soft start and run that over to your common for your compressor, your black wire for your compressor. Then they're actually going to take in the other end of the green connector, you're going to put the blue wire. There's actually 3 terminals there, but you're not going to use the middle terminal at all. So you're going to connect your blue wire, and then you're going to run it to your HERM on your start capacitor. Then the last wire that you're going to run is you're going to run they actually give you a real thick red wire, and you're going to run that from here right above where you just connected that blue wire, but it's going to be in the gray part of the sure start or soft start, and you're going to run that over to where we disconnected this right here, and you're going to put it in right next to where the common was. Don't put it on the common, because that's where the red one, in my case, it was a yellow wire. So we had to go to Home Depot and buy a terminal end for that and crimp that on there. That was the only thing we needed to buy. It was like $3, and you got like 10 in a pack. So then, when you're done with that, you're wired up. So the one thing you want to make sure is, before you start anything, disconnect your fuse and go turn off your breakers for everything, because your A coil, for me up in the attic, has live 220 going to that as well. So you want to turn off everything that could have any power going to it. So then you wire it up, put it back to where it's wired up, turn your power back on, put your breaker on, and you fire it back up. And right now, our battery is charging up to 54.4. And let's see. Got 72 amps coming in, 4 kilowatts. And our load is 49%. So it's right around 3 kilowatt. And we're using 2.8 kilowatts, nothing coming out of our battery. So we're completely running this off the solar that we're producing. Same thing over here. This is at 51 for that 4-ton, and we're bringing in 77 amps, 3.96 kilowatts, almost 4 kilowatts we're producing. And it is 3.6 kilowatts that we're using, not using anything out of our battery bank. So we can run these things all day long. Now, on this one, we have 16 panels on one array, and on the other array we have 14 panels. So it's 7,000 watts coming in here, and those are used poly panels. On this 6 kilowatt, we have 16. We have probably about 24 panels coming into this right now of the poly panels, 250 watts. So it's 6,000 watts coming into that. So perfectly running it. Like I said before, this 6 kilowatt Growatt low frequency inverter did not have enough on its own to start up that 3.5 ton. But with that soft start, which was $249, we're now able to start it up. We reduced our inrush amps from 72 to 75 down to 16 to 20, 24, somewhere around there. Huge reduction, over a third less. So it's like 60, 70% less inrush currents to start this thing up. So very happy with this. Now I'm going to take and see if I can turn this 18,000 BTU mini split that's 230 volts, see if I can run it at the same time as this and see if it drags it down. Oops. Okay, so we have it set at 86, but it's actually 91 degrees in here. So if we look at this, okay, we're already starting to drop. We are 54.5. Now we're down to 53, 52.87, 52.5, 52.4. We'll see how, if this is able to keep running this, because this usually uses around 1,500 to 2,000 watts, 1.5 to 2 kilowatts. It might be too much for this right now. Yeah, it tripped it. But that's okay. We can go check our inrush current on our 6 kilowatt inverter. As soon as this breaker resets, we will go out there and we can go out there right now and reset that. So yeah, I was just using too much. So we'll have to go and wire that back up to either the 12 kilowatt or to the 5,000 watt MPP, because that ran fine off of that. So let's put this back on here and hit max and put that on for the inrush. Let's go see if our breaker is ready to reset. Man, it's staying nice and cold in here. Really blows cold air. These air conditioners are only like 3 years old, so they really blow cold air when they fire up. Okay, so we got that going. We reset the breaker on that. Let's see if we can, there we go. Okay, so this is starting back up. Turn this on, turn this on. And we'll turn that off. Okay, so we got that turned back off. And give that a second for the solar panels to connect again. And we'll see what kind of a drop we have on the screen here. And then also what our inrush amps are out there as soon as this connects the solar panels. Give it a second. And get a sip of coffee. So this took about a half hour to wire up. Took about another 10 or 15 minutes to run to Home Depot. Oh, don't have the, I didn't turn the output power on. There we go. There was a drop there from 52 down to 49.4. So we're actually running at 2.87 kilowatts, but our solar panels haven't connected yet. Oh, didn't like that. But while we're waiting for that, we'll go see what our inrush current was. It is hot and humid today. It's supposed to get up to like 112 or 113. Okay, so our inrush was only 18.2 on the soft start versus 72 to 75 amps. That's pretty darn good. So that's 75% reduction in amps. And the more you run it, the more it learns, and it teaches itself with your compressor. So it's meant to do that so that when it starts up, it gets more efficient. So we'll start this back up again. And we can, just a second, we can disconnect that air conditioner up there because I think it was dragging it down because it was still pulling amps. So we're going to wait until the solar panels connect up again on this. And then we'll start up that. There we go. So the solar panels connected on there. And we're starting to charge your battery up again. So we'll get up to around 55, 56. There we go, we're 57.2. Okay, that dragged it down to 51.7, 51.6, and it started it up. So 52, so we're climbing again. So it dropped it down to 51.7 or 8, and now it's back up again, and the solar panel input is bringing it back up. So we have 72 amps coming in off our solar panels, 3.87 kilowatts. And we're using 3.02. So we're 0.8 kilowatts, 800 watts more than we need. And we're up to 53. We're hanging right around 52.9, 53. So pretty nice being able to run my whole house air conditioners upstairs and downstairs off of just solar. I walk in from that garage to this inside. It is cold. So here we go, outside, and we have both of them running. And I doubt, oh, it did give us. So it was 22.7 inrush on that last one start. And if we get rid of that, we're running 11 amps right now. So, see, 7 amps on that, and 9 amps. So it's around 20 amps between the two. Anyways, just want to let you know these hyper starts are well worth the money. I saw another one, but I couldn't find anywhere to buy it. Now the other thing about these is they sell them in 120 volt single phase that you can use on your motorhome, which I'm going to get. I'm also going to get one for this 4-ton so that it'll drop that down. I heard someone say the inrush on this is about 119 amps and it'll drop it down to about 45 amps. I like that. So a lot softer start. No compressor and stuff doesn't have to work so hard. Anyways, half-hour worth of work. Probably going to have to run to Home Depot and buy one piece. It's like $3. You'll get 10 in a thing. You only need one. And we'll put this thing back together. But when you go to order, just look on here on your panel for your compressor right there. The compressor's 208, 230. It's one phase, 60 hertz. Your running amps are 15.1 and your inrush amps are 75 on this unit. So if we go down here, we looked at where our minimum circuitry is 20 amps and our max fuse is 30 amps for our fuse on the wall there. So this is a carrier unit that it's only 3.5, 4 years old, relatively new. We just had them replaced. The originals were on since 2003, so they lasted us about 16 years before we replaced them. Now we have AC and heat year-round running off of just solar. So just need to start working on building our battery bank so we can either run these at night or we'll be able to run our mini splits in the bedrooms. So please like, share, subscribe, and hope you have a wonderful and truly blessed day. And we'll see you soon.